In this example, we are going to try to figure out what the slope equation is for this graph. So if we graph this thing, what would be the slope at any point? And we can use this function to figure that out. So we don't need to find any point. We just need to generalize this and figure out what's the slope equation. So AKA we're doing the derivative, but we're doing the derivative with limits. So let's start it off by g prime of t is going to be the limit as h goes to 0 of g of t plus h minus g of t divided by h. Right, so that's kind of our generic one, and I'm just replacing the letters to make it appropriate to match this. All right, so here comes the math. So here's the algebra to this. So I'm going to take this equation and I'm going to replace my t with t plus h, and then we'll square it. So we have the limit as h approaches 0 of 1 over t plus h squared minus 1 over t squared divided by h. All right, so that's step one, is just kind of subbing it in. Step two is, now we need to manipulate this, because if I plug in 0, if I plug 0 in for h, I would get a 0 over 0, which implies that the limit exists, but I can't do anything with the 0 of 0. So we got to finagle. So let's mess with this equation a little bit. Let's make common denominators happen. So I would multiply the top and the bottom by t squared, and I would multiply this by a t plus h squared. T plus h squared, top and bottom. All right, so this is going to allow me to put this whole thing together. Okay, and we'll do that in a couple steps here. So right now I would have t squared over t squared t plus h squared minus t plus h squared over t squared t plus h squared. All right, so there's our common denominator. There it's matching, and then we just kind of, these are what we needed to fill the numerators with the denominators to kind of make everything match. So we still have that still all over the other h here. So I want to put this together, combine our like terms, and let's see what we got. So we have the limit as h goes to 0, and we're going to have t squared minus. So I'm going to combine them together. I'm going to multiply this through. So when I multiply that through, I'll get a t squared plus 2t h plus h squared, and over this common denominator, and then over the h. Okay, now I'm going to kind of clean up this over the h thing. I got too many fractions going on. So I'm going to multitask here a little bit. So we're going to combine, we're going to distribute this negative through, and at the same time, I'm going to, instead of dividing by h, I'm going to multiply the reciprocal. All right, so I have t squared minus 2t h minus h squared when I distribute that over t squared times t plus h squared, and then instead of dividing h, we're going to multiply by the reciprocal. All right, so here's what should be happening. I should be able to combine pieces together here, and anything that doesn't have an h on it should go away. That's a common theme with this. We should have something that has h's that I could factor an h out. So limit as h goes to 0, we have an h that we could take out of this, which would leave us with a negative 2t minus h over t squared t plus h squared times 1 over h. All right, so h's go away. That's great, because that was where we were getting our 0 on the top, and that's where we were getting our 0 on the bottom. So wonderful. We are left with about to get rid of our limit. Not yet. Let's rewrite, and then we can plug 0 in. So we would have a negative 2t minus h over t squared t plus h squared. All right, so now ready to plug in 0. So we have a negative 2t minus 0 over t squared times t plus h, which is now 0 squared. All right, so clean all that up. We are left with a negative 2t over t to the 4th, because that's a t squared and that's a t squared, and then we'll simplify that. So that's going to become a negative 2 over t to the 3rd. And that represents our slope equation. Negative 2 over t to the 3rd. All right, that problem was very algebra heavy, common denominators, all that stuff. There is some shorter methods that we will eventually learn about this, but right now we're just doing the limit to create this, and it gets a little bogged down because of the common denominators and all the variables all mixed together. But that is our slope equation for this problem.